Okay, here it's saying, given the following sequences, is it arithmetic or geometric? And then write the recursive and the explicit. So if you're looking here, picture that on a number line, this is going further and further down into the negative. And so you could grab a calculator and do -16 minus a -17. So what you're going to notice, -16 minus a -7 and -25 minus a -16, what you're going to notice is it's going, you got it, down by 9. -9, -9, -9. So since it's subtracting, we're going to say that this is arithmetic. And so writing the recursive, we're going to say f of 1 equals -7, and f of n equals f of n minus 1 minus 9. That's the pattern that's happening every time. And then we go write the explicit. Begins with -7 subtracting 9 every time to the big N minus 1. So where do all these numbers come from? Remember that this begins with -7 comes from right there. This minusing 9 comes from right there. And finally, this 1 comes from right here. Okay, let's go look at the next one. When you're jumping from a fraction to a number, sometimes it's easier to look at it in the future steps, like the -4 to 32, the 32 to 256. So first, could I be adding the same number? Well, it's going negative, positive, negative, positive. So this is actually looking more geometric. So let's try multiplying by something. 4 times 8 makes 32. Test it on your calculator. Does 32 times 8 make 256? And it does. So we know there's an 8 in there. Now what about the sign? Times 8 times 8 times 8. But if we need to go from positive to negative, negative to positive, positive, do you see that there should be a negative in there as well? So if I multiply by -8, does that now make sense? So this one is a geometric because we're multiplying by that common ratio of -8. So f of 1 equals 1/2. F of n equals f of n minus 1 times -8. Explicit begins with 1/2 times -8 to the power of little tiny n minus 1. Where do all these parts come from? Remember that the begins at 1/2 starts there. The times 1/8, times 8 comes from there. And then the power of n minus 1 comes from right here. All right, looking at this last one, notice it's going from 1350 to 450, 450 to 150, 150 to 50. So it's a decreasing pattern. But if I just subtract a constant number like 150 minus 50, that'd be going down 100. 450 to 150, that's going down 300. So this is not subtracting by the same thing. It means it needs to be a geometric that's multiplying by a fraction. So I'm grabbing my calculator to test it out by doing the following. 50 divided by 150 gives me 0.3333 repeating. 150 divided by 450. Hey, look, it gives us also 0.3333. And then 450 divided by 1350. That also gives us 0.333. Okay, so what fraction is actually equal to that 0.33333? You got it. Our fraction multiplier, our common ratio, is 1/3. Okay, so let's go write the recursive with this times 1/3. So f of 0 this time, check it out. Make sure you caught that. F of n equals f of n minus 1 times 1/3. And finally, begins at 1350 timesing by 1/3, every time to the power of n. Now, because this is a time 0, you can just write n, or you can write n minus 0. It's the same thing. Where do all these parts come from? This 0 comes from right there. Begins with 1350, and multiplying by that 1/3 came from that division work we did at the beginning. Okay, how are you doing on writing the recursives and explicits?